Calculate the amount of carbon dioxide that could be produced, okay, when 1 mole of carbon is burnt in air. That's very simple. C plus O2 gives CO2. Now, what does amount means? Amount means moles, volume, mass. Actually, it could be anything, but often it refers to mass. Okay, so let's try. If I have 1 mole carbon, and if it is totally burnt, it will give me 1 mole CO2. And molar mass of CO2, how much is that? Molar mass of CO2 is 44 grams per mole. Therefore, mass of CO2 is moles into molar mass, which is 44 into 1, which is 44 grams. So I would get 1 mole of CO2 or 44 grams of CO2. Right? Right. 1 mole of carbon is burnt in 16 grams of oxygen, dioxygen. Fine. So if I have carbon 1 mole, and if I have O2, dioxygen, and I am told this is 16 grams. Now 16 grams of O2. Now mass of O2 is 16 grams. Therefore moles of O2 is mass by molar mass, 16 by 32, and molar mass of oxygen, it's 32. So this comes out to be 0.5 moles. Oh, is it 0.5 moles alone? Yes, it's just 0.5 moles. And I'm getting CO2, of course I'm getting CO2. So initially, this is the reactant. Now, please note, O2 is no longer in excess, it is less. So, let us say how much can react. Maximum 0.5 can go, maximum 0.5 can go, and maximum 0.5 is formed by stoichiometry. You can see number of moles, the ratio is 1:1:1. Whatever is the number of moles of O2 reacting, same is the number of moles of carbon reacting, and same is the number of moles of CO2 produced. Right? Right. What do I get? I get 0 here. I get 0.5 moles. That means 0.5 moles of carbon remain unreacted. And how much I get? I get 0.5 moles of CO2. Please remember, 1 mole was 44 grams. So 0.5 moles would be 22 grams of CO2. I just land up with 22 grams of CO2. That's all. Fine. Third says 2 moles of carbon are burnt in 16 grams of dioxygen. Now please understand, in the third part, I'm just changing second part only into third part, and it has a very, very important message. If I increase the amount of carbon from 1 mole to 2 mole, please remember, carbon was already extra. We were left with certain amount of carbon. Now, instead of 0.5 mole, I would be left with 1.5 moles of carbon because it is the excess reagent, which is less. The lesser reagent is called limiting reagent, and in both 2 and 3, limiting reagent is dioxygen. Limiting reagent gets exhausted, it is reduced to 0, and if there is no more oxygen, obviously more carbon cannot burn. The amount of carbon burned is exactly the same. Extra carbon just remains unreacted at the end. Amount of CO2 produced is again 0.5 mole or 22 grams only in part 3 also. This is a very good learning from here, that if you increase the excess reagent, amount of product is not changed. If you increase limiting reagent, only then more reaction takes place and the amount of product can be increased. So what is the answer? This is the answer for 2 and 3. They have same answer, 2 and 3, that is 22 grams of CO2.